The Biology of Belief by Bruce Lipton, Ph.D. Chapter 6, Growth and Protection. Evolution has provided us with lots of survival mechanisms. They can be roughly divided into two functional categories, growth and protection. These growth and protection mechanisms are the fundamental behaviors required for an organism to survive. I'm sure you know how important it is to protect yourself. You may not realize, though, that growth is vitally important to your survival as well, even if you're an adult who has reached your full height. Every day, billions of cells in your body wear out and need to be replaced. For example, the entire cellular lining of your gut is replaced every 72 hours. In order to maintain this continuous turnover of cells, your body needs to expend a significant amount of energy daily. By now, you won't be surprised to learn that I first became aware of how important growth and protection behaviors are in the laboratory, where my observations of single cells have so often led me to insights about the multicellular human body. When I was cloning human endothelial cells, they retreated from toxins, and I introduced into the culture dish, just as humans retreat from mountain lions and muggers in dark alleys. They also gravitated to nutrients, just as humans gravitate to breakfast, lunch, dinner, and love. These opposing movements define the two basic cellular responses to environmental stimuli. Gravitating to a life-sustaining signal, such as nutrients, characterizes a growth response. Moving away from threatening signals, such as toxins, characterizes a protection response. It must also be noted that some environmental stimuli are neutral. They provoke neither a growth nor a protection response. My research at Stanford showed that these growth/protection behaviors are also essential for the survival of multicellular organisms such as humans. But there is a catch to these opposing survival mechanisms that have evolved over billions of years. It turns out that the mechanisms that support growth and protection cannot operate optimally at the same time. In other words, cells cannot simultaneously move forward and backward. The human blood vessel cells I studied at Stanford exhibited one microscopic anatomy for providing nutrition and a completely different microscopic anatomy for providing a protection response. What they couldn't do was exhibit both configurations at the same time. In a response similar to that displayed by cells, humans unavoidably restrict their growth behaviors when they shift into a productive mode. If you're running from a mountain lion, it's not a good idea to expend energy on growth. In order to survive, that is, escape the lion, you summon all of your energy for your fight or flight response. Redistributing energy reserves to fuel the protection response inevitably results in a curtailment of growth. In addition to diverting energy to support the tissues and organs needed for the protection response, there is an additional reason why growth is inhibited. Growth processes require an open exchange between an organism and its environment. For example, food is taken in and waste products are excreted. However, protection requires a closing down of the system to wall the organism off from the perceived threat. Inhibiting growth processes is also debilitating in that growth is a process that not only expends energy, but is also required to produce energy. Consequently, a sustained protection response inhibits the creation of life-sustaining energy. The longer you stay in protection, the more you compromise your growth. In fact, you can shut down growth processes so completely that it becomes a truism that you can be scared to death. Thankfully, most of us don't go to the scared to death point. Unlike single cells, the growth/protection response in multicellular organisms is not an either-or proposition. Not all of our 50 trillion cells have to be in growth or protection mode at the same time. The proportion of cells in a protection response depends on the severity of the perceived threats. You can survive while under stress from these threats, but chronic inhibition of growth mechanisms severely compromises your vitality. It is also important to note that to fully experience your vitality, It takes more than just getting rid of life stressors. In a growth protection continuum, eliminating the stressors only puts you at the neutral point in the range. To fully thrive, we must not only eliminate the stressors, but also actively seek joyful, loving, fulfilling lives that stimulate growth processes. The biology of homeland defense. In multicellular organisms, growth protection behaviors are controlled by the nervous system. It is the nervous system's job to monitor environmental signals, interpret them, and organize appropriate behavioral responses. In a multicellular community, the nervous system acts like the government in organizing the activities of its cellular citizens. When the nervous system recognizes a threatening environmental stress, it alerts the community of cells to impending danger. The body is actually endowed with two separate protection systems, each vital to the maintenance of life. The first is the system that mobilizes protection against external threats. It is called the HPA axis, which stands for the hypothalamus pituitary adrenal axis. When there are no threats, the HPA axis is inactive and growth flourishes. However, when the brain's hypothalamus perceives an environmental threat, it engages the HPA axis by sending a signal to the pituitary gland, or the master gland, which is responsible for organizing the 50 trillion cells of the community to deal with the impending threat. Think back to the cell membrane stimulus response mechanism, the receptor effector proteins. The hypothalamus and pituitary gland are behavioral equivalents. Similar to the role of a receptor protein, the hypothalamus receives and recognizes environmental signals. The pituitary's function resembles that of the effector protein in that it launches the body's organs into action. In response to threats from the external environment, the pituitary gland sends a signal to the adrenal glands, informing them of the need to coordinate the body's fight or flight response. The technical details of how the stress stimuli engage the HPA axis follow a simple cascade. In response to perceptions of stress registered in the brain, the hypothalamus secretes a corticotropin release factor, or CRF, which travels to the pituitary gland. CRF activates special pituitary hormone-secreting cells, causing them to release adrenocorticotropic hormones, or ACTH, into the blood. The ACTH then makes its way to the adrenal glands, where it serves as the signal to turn on the secretion of the fight-flight adrenal hormones. These stress hormones coordinate the function of the body's organs, providing us with the great physiological power to fend off or flee from danger. Once the adrenal alarm is sounded, the stress hormones released into the blood constrict the blood vessels of the digestive tract, forcing the energy-providing blood to preferentially nourish the tissues of the arms and legs that enable us to get out of harm's way. Before the blood was sent to the extremities, it was concentrated in the viscera, in the visceral organs. Redistributing the viscera's blood to the limbs in the fight or flight response results in an inhibition of growth-related functions. Without the blood's nourishment, the visceral organs cannot function properly. The visceral organs stop doing their life-sustaining work of digestion, absorption, excretion, and other functions that provide for the growth of the cells and the production of the body's energy reserves. Hence, the stress response inhibits growth processes and further compromises the body's survival by interfering with the generation of vital energy reserves. The body's second protection system is the immune system, which protects us from threats originating under the skin, such as those caused by bacteria and viruses. When the immune system is mobilized, it can consume much of the body's energy supply. To get a sense of how much energy the immune system expends, recall how physically weak you become when you are fighting infections, such as a cold or a flu. When the HPA axis mobilizes the body for fight or flight response, the adrenal hormones directly repress the action of the immune system to conserve energy reserves. In fact, Stress hormones are so effective at curtailing immune system function that doctors provided them to recipients of transplants so that their immune system couldn't reject the foreign tissue. Why would the adrenal system shut down the immune system? Imagine that you're in your tent at the African savannah suffering from a bacterial infection and experiencing a bad case of diarrhea. You hear the gutty growl of the lion outside your tent. The brain must make a decision about which is the greater threat. It will do your body no good to conquer the bacteria if you let a lion maul you. So your body halts the fight against the infection in favor of mobilizing energy for flight to survive your close encounter with a lion. Therefore, a secondary consequence of engaging the HPA axis is that it interferes with your ability to fight disease. Activating the HPA axis also interferes with your ability to think clearly. The processing of information in the forebrain, the center of the executive reasoning and logic, is significantly slower than the reflex activity controlled by the hindbrain. In an emergency, the faster the information processing, the more likely the organism will survive. Adrenal stress hormones constrict the blood vessels in the forebrain, reducing its ability to function. Additionally, the hormones repress activity in the brain's frontal cortex, the center of conscious volition action. The center of conscious volition reaction. In an emergency, the vascular flow and hormones serve to activate the hindbrain, the source of life-sustaining reflexes that most effectively control fight or flight behavior. While it is necessary that stress signals repress the slower processing conscious mind to enhance survival, it comes at a cost. Diminished conscious awareness and reduced intelligence. Fear kills. Remember the shell-shocked, frozen look on my Caribbean medical students' faces when they failed my test, the medical school equivalent of a voracious lion? Had my students stayed frozen in fear, I can guarantee you that they would have performed dismally on their finals. The simple truth is, when you're frightened, you're dumber. Teachers see it all the time among students who don't test well. Exam stress paralyzes these students who, with trembling hands, mark wrong answers because in their panic, they can't access cerebrally stored information they have carefully acquired all semester. The HPA system is a brilliant mechanism for handling acute stresses. However, this protection system was not designed to be continuously activated. In today's world, most of the stresses we are experiencing are not in the form of acute, concrete threats that we can easily identify, respond to, and move on. We are constantly besieged by multitudes of unresolvable worries about our personal lives, our jobs, and our war-torn global community. Such worries do not threaten our immediate survival, but they nevertheless can activate the HPA axis, resulting in chronically elevated stress hormones. To illustrate the adverse effects of sustained adrenaline, let's use an example of a track race. An extremely well-trained and healthy group of sprinters step up to the starting line. When they hear the command, "On your marks," they get on their hands and knees and adjust their feet into the starting blocks. When the starter barks out, "Get set," the athletes' muscles tighten as they prop themselves on their fingers and toes. When they shift into get set mode, their bodies release a flight-promoting adrenaline hormones that power their muscles for the arduous task ahead. While the athletes are on hold awaiting the go command, their bodies are straining in anticipation of that task. In a normal race, that strain lasts only a second or two before the starter yells, "Go!" However, in our mythical race, the go command, which would launch the athletes into action, never comes. The athletes are left in the starting blocks, their blood coursing with adrenaline, their bodies fatiguing with the strain of preparing for the race that never comes. No matter how toned their physique, within seconds, these athletes will physically collapse from the strain. We live in a get-set world, and an increasing body of research suggests that our hypervigilant lifestyle is severely impacting the health of our bodies. Our daily stressors are constantly activating the HPA axis, priming our bodies for action. Unlike competitive athletes, the stresses in our bodies are not released from the pressures generated by our chronic fears and concerns. Almost every major illness that people acquire has been linked to chronic stress. In a revealing study published in 2003 in Science, researchers considered why patients on SSRI antidepressants such as Prozac or Zoloft don't feel better right away. There is usually at least a 2-week lag between starting the drugs and the time the patients feel they are getting better. The study found that depressed people exhibit a surprising lack of cell division in the region of the brain called the hippocampus, a part of the nervous system involved with memory. Hippocampal cells renewed cell division at the time patients first began to experience the mood-shifting effect of the SSRI drugs, weeks after the onset of the drug regimen. This study and others challenge the theory that depression is simply the result of a chemical imbalance affecting the brain's production of monoamine signaling chemicals, specifically serotonin. If it were as simple as that, the SSRI drugs would likely restore that chemical balance right away. More researchers are pointing to the inhibition of neuronal growth by stress hormones as a source of depression. In fact, in chronically depressed patients, the hippocampus and the prefrontal cortex, the center of higher reasoning, are physically shrunken. A review of the study published in Science reported, overtaking the monoamine hypothesis in recent years has been the stress hypothesis, which posits that depression is caused when the brain's stress machinery goes into overdrive. The most prominent player in this theory is the hypothalamic pituitary adrenal axis, the HPA axis. The HPA axis's effect on the cellular community mirrors the effect of stress on a human population. Picture a vibrant community back in the Cold War years, when the possibility of a nuclear attack by the Russians weighed heavily on Americans' minds. Like cells in a multicellular organism, the members of this Cold War society actively work at jobs that contribute to the community's growth and usually get along with each other. Factories are busy manufacturing, construction people are building new homes, grocery stores are selling food, and kids are in school learning their ABCs. The community is in a state of health and growth, while its residents constructively interact towards a common goal. Suddenly, the sound of an air raid siren rocks the town. Everyone stops working to run off, seeking the safety of bomb shelters. The harmony of the community is disrupted as individuals, acting only in support of their own survival, fight their way to a bomb shelter. After 5 minutes, the all-clear sound signals. Residents return to their jobs and resume their lives in a growing community. But what would happen if the sirens sound, the residents run into their air raid shelters, and there is no all-clear signal to release them? People would stay in their protective postures indefinitely. How long can they maintain their protection posture? The community eventually collapses in the face of dwindling food and water supplies. One by one even, the strongest die because chronic stress is debilitating. A community can easily survive short-term stress, like an air raid drill, but when the stress goes on, it results in cessation of growth and the breakdown of the community. Another illustration of the influence of stress on a population is the story of the 9/11 tragedy. Up to the moment the terrorists attacked, the country was in a state of growth. Then immediately after 9/11, as the shock of the news spread to reach not just the people of New York, but the entire nation, we experienced a threat to our survival. The impact of government proclamations stressing the continued presence of danger in the wake of the attack was like the influence of the adrenal signals. They shifted the members of the community from a state of growth to a state of protection. After a few days of this heart-stopping fear, the country's economic vitality was so compromised that the president had to intervene. To stimulate growth, the president repeatedly emphasized, "America is open for business." It took a while for the fears to subside and for the economy to rebound. However, the residual threats of terrorism are still debilitating the vitality of our country. As a nation, we should look more carefully to how our fear of future acts of terrorism is undermining our quality of life. In some sense, the terrorists have already won, since they have succeeded in frightening us into a chronic, soul-sapping, protective mode. I'd also like to suggest that you examine how your fears and the ensuing protection behaviors impact your life. What fears are stunting your growth? Where did these fears come from? Are they necessary? Are they real? Are they contributing to a full life? We'll deal more with these fears and where we got them in the next chapter on conscious parenting. If we can control our fears, we can regain control over our lives. President Franklin D. Roosevelt knew the destructive nature of fear. He chose his words carefully when he told the nation in the grips of the Great Depression and looming World War, "We have nothing to fear but fear itself." Letting go of our fears is the first step towards creating a fuller, more satisfying life.